Welcome to Evaluation in Artificial Intelligence. So let us see what are the topics we are going to cover here. Evaluation is the fifth stage of AI project cycle where a model is tested. The word evaluation itself means to test. So the model is tested here to see how it functions. So we will be seeing here importance of model evaluation, then splitting of the training set data, something called accuracy and error, evaluation metrics for classification model, and ethical concerns around model evaluation. What are the ethics that has to be followed? So model evaluation is an integral part of the model development process. It helps to find the best model that represents our data and how well the chosen model will work in the future. We need evaluation to know the strengths, the weakness, and suitability of the model. If a model is not suitable after evaluation, we go back to the previous stages of the project cycle. We might go back to the modeling stage. We might go back to the data exploration. If there's some issue with data, we might have to go back to the data acquisition phase. So after evaluation, if we find our model is not suitable, so it's like a feedback. It's like a feedback. We go back to the previous stages and again select a different model. There are certain terms which you have to know after evaluation. Is a model can be overfit, underfit, or perfect fit. So let us quickly see what these terms mean. Overfit means the model has learned the data during the training time. It has learned, it has memorized the training data. It's same like if your teacher is giving you a sample paper for the upcoming exam and you are learning the sample paper. You are not understanding the concept. So model is not trying to find the pattern of the data. It is not seeing the relationship or the trend in the data. It is learning the data. So if a model learns the data, it cannot perform well with unseen data. So an overfit model performs very well when it is tested with training data itself, but not with any new data. So it has memorized the training data and it cannot perform well with any unseen data. So we cannot take a model further if it is a overfit model. Underfit, as you can understand, it's same like if your teacher is giving you a sample paper to practice before the exam, you are not doing that sample paper also. Underfit, it has not learned anything. It has neither learned the data, it has neither tried to see or the pattern of the data, the trend of the data. So its performance is too low, underfit. So we cannot go for an underfit model also. So we will go for a perfect fit model. So it is that model which has learned the pattern and trend of the data and it will perform good with unseen data. So always after evaluation, we have to go for a perfect fit model. Splitting of the training set data for evaluation. So one thing you have to know that after the problem scoping stage is the data acquisition stage. In the data acquisition stage, we take the data and we split it into two parts. The ratio can either be 80-20 or 70-30. It is like the larger portion of the data is used for training the model. So whenever we collect any data, we divide it into two parts, the training data set and testing data set. This is done during the evaluation phase, and the training data set is used to teach the model, and the testing data set is used to evaluate or test the model after the training is over during the modeling stage. So, and this is a must training testing split, because if we don't test a model, we won't know the performance of the model, whether it is suitable for deployment or not. So we have to perform train test split. Two very important terms, accuracy and error. And you will get questions on accuracy and error also. So let's try to understand what is accuracy and error. Accuracy actually measures how many predictions made by the AI model are correct out of the total predictions. Once again, what is prediction? Output given by AI model is called prediction. The output that the AI model gives is called prediction. Accuracy measures, I'm repeating once again, accuracy measures that out of all the total predictions, how many are correct. And error. What is error? Error actually shows us that out of how many predictions made by AI model are incorrect. So how many are incorrectly predicted? That is error. Say for example, if we have uh, our model gives 90 correct answers out of 100. There are 100 times we are testing the model and 90 times it is giving correct answer. Accuracy will become 90% of that model, because 90 times it has given correct answer. And error, what is the error? And if so, if 10 answers are wrong out of 100, so error will be 10%. So error focuses on the incorrect thing and the accuracy focuses on the correct part. So model evaluation basically stands on these two pillars of accuracy and error. So our goal should be minimizing error and maximizing accuracy. You must always remember that the real world data is very complicated, it is messy, and you should know how to calculate accuracy and error. So this column, this feature is the predicted house price in USD. This is the actual house price. So if you have to calculate the error, you will subtract the predicted from the actual price. And error rate will be error divided by the whatever error is coming by the actual. That's the error rate. And so what will be accuracy? Accuracy will be just 1 minus error rate. Because error rate represents the incorrect fraction of the prediction and subtracting it from 1 gives the correctly predicted fraction. Because error plus accuracy will always be 1. So once we get the error rate, accuracy can be calculated just by subtracting error rate from 1 and converting it to percentage. Next comes evaluation metrics for classification model. We are doing only for classification model. So a classification algorithm is an AI method used to assign input data into predefined classes. This I have already discussed in the topic of advanced concepts of modeling. You can go through that. So here the algorithm learns from label data and then predicts the correct class for new data. So that is what is classification. And a classification map looks like this. This also we discussed in the advanced concepts. So what are the metrics? What are the metrics Mark this word. What are the metrics used for classification model? That is, what are the factors we used to see how our model is performing. So classification metrics are the measures used to evaluate or test the performance of the classification model. Also, we can say these helps us to understand how correctly the model is predicting the class levels. So we can also say classification metric tells us how good or bad an AI classifier is. So we need to create something called confusion matrix. We calculate accuracy, precision, recall, and F1 score for a particular model. Okay, so let us try to understand the confusion matrix, or we'll take a scenario. So the first is confusion matrix. So this is a scenario of a forest fire. Now, actually there is fire, and our model is, suppose a model will be predicting it. So what can be the outputs of the model? Let us check with that. The first scenario is actual, there is fire. Yes, we can see there is fire. And prediction. The model has also said yes, there is fire. Yes, for yes, we can also write 1. Better you write like this, yes, and then in bracket 1. Yes. So actual is also yes, prediction is also yes. So this type of situation is known as true positive. This type of situation is known as true positive, where actual and the prediction is the output of the model, both are matching. That's why this word true comes. Why is it true? Because actual and prediction both are matching. That's why the word is true. And positive means the prediction is yes. If the prediction is yes, this part, second part will be positive. If prediction is no, it is negative. So if I see true positive anywhere, if I see a true positive situation anywhere, I will clearly understand that prediction is positive. Yes, for any case. It can be for any case. Prediction is positive and it has actually matched the actual part. So this is the first scenario where both are yes, and this is called true positive. Second scenario is there a forest fire? No, there is not no forest fire. We can see there is no fire. And the case is actual, it is no. And prediction is also saying no. So again, actual and prediction are matching. Model is giving perfectly correct answer. Both actual and prediction are matching. So this case is called, since actual and prediction are matching, it's called true, and prediction is no. So it's true negative. I hope you understood how we got true negative. Since actual and prediction are matching, they are matching. That's why it is true and negative. So model has said there is no fire, and in reality also there is no fire. So perfect state. So first is true positive, second is true negative. Let's check out with the third stage. Once again, is there a forest fire? Now this time, yes, actually it is a fire, but our prediction is saying no. Our model, for some reason, it's an error case, model is saying no. So this is an error case. And what is this state called? Since actual and prediction are not matching, they are not matching, so it's false. It's false. And since prediction is no, it is negative. So this state is called false negative. So this is the third stage, and let's quickly move on to the fourth one. So once again, actual is no, there is no fire. Prediction, yes, there is fire. It's not matching, so it's false. Since prediction is yes, it's false positive. So this is another error state. So false negative and false positives are our error state. So we should always have a model which gives us lesser number of false positives and false negatives. The same table, if both actual and prediction are matching, it's TP, true positive. You might get question to explain what is TP, TN, FN, FP. You have to first write the full forms of this. TP is true positive, and it means the actual and prediction are matching, and the prediction is positive. So this way you have to go with the explanation. You can refer to this also for explaining. True positive means prediction and reality or actual are matching, that's why true, and prediction is true, that's why positive. Second part is always related to the prediction. Second part is always related to the prediction. And you will also you should also know how to draw a confusion matrix. So confusion, for drawing a confusion matrix, first you draw a big rectangle. Don't make a smaller one, make a big rectangle. Then you divide the rectangle into reality and this side prediction. Reality, and then the reality can be yes, no. Prediction can be yes, no. So the first cell, this particular cell, is reality is also yes, prediction is also yes, it's true positive. Coming to this one, reality is no, prediction is yes, so they are not matching. It is false, and prediction is yes, so false positive. This stage, reality no, sorry, reality yes, prediction no, again not matching, so it's false, and negative state, prediction is no, final is true negative. So you will get questions like, you might have to create a confusion matrix where the statements will be given. You have to find out how many true positive cases are there, how many false positive cases are there, draw a good confusion matrix and write down. So when you're drawing the confusion matrix, make sure you're writing reality this side, prediction yes, no, you're not missing out any of these stages. And inside also you're writing the number along with TP, FP, these states. Some of the examples of TP, TN, FP, and FN are: model had predicted that France would win the World Cup and it won. So it's a case of true positive because France really won and the model had also said yes. And since the model said yes, it's positive, so true positive. Model predicted that Germany would not win and it lost. So it's case of true negative. Model predicted Germany would win, but it lost. So model's prediction was positive, it will win, positive, but it lost. So mismatch and positive. So false positive. And the last case is model had predicted France would not win, but it won. So model was wrong. And now again, reality and prediction are not matching. It's negative, false negative. Next comes evaluation metrics. So we understood confusion metrics before this. Now we have to know evaluation metrics. There are 4 evaluation metrics for classification model: accuracy, precision, recall, and F1 score. So we do not judge an AI model just by looking at the predictions. We need numbers to tell us how accurate or how wrong the predictions are. So evaluation metrics helps us to compare models and improve them. Do not forget these 4 names. These can be asked in any form to you. And always remember, these are the evaluation metrics for classification model. We are doing the evaluation for classification model only. So the first one is accuracy. So accuracy actually tells us how many predictions that is made by the AI model are correct out of all predictions. AI model is giving us lots of predictions. So how many are actually correct? So it gives the overall performance of the model. So we have a formula for this. The formula is the same thing here. Accuracy is correct predictions by total cases. So total cases are always summing up all the TP, TN, FN, and FP. So first you have to find out these 4 states, TP, TN, FN, FP, and you just have to summing up of the accuracies, correct predictions. So we know the false negative and false positives are error stages. So the correct predictions are true positive and true negative. So this is how we calculate accuracy. And after you calculate accuracy, you either leave the answer in percentage, multiply by 100 and convert it to percent, or you leave it into decimal. Do not leave in fractions. Either leave in decimals up to 2 decimal points or leave it in percentage. So this is your accuracy, the first evaluation metric. Let's move on to the second one. Okay, before moving on to the second one, we have got some problem with accuracy, or why is the second one needed? That is necessary. So this is a case. This is a case. Our model is always saying no, there is no forest fire. Always. Whenever we test the model, we ask the model, it's saying no, there is no forest fire. But in reality, there are 2 times, since it's percent, we can say there are 2 times out of 100 times where there was fire, but the model said no. So accuracy of this model, let's try to calculate the accuracy of this model. So please remember, prediction is always no, and reality is, prediction is always no, and reality is 2% times, 2 times there was fire, but it said no. So since prediction is always no, true positive is 0, because it is never saying there is fire. There's fire, no, there is no fire. So true positive, it is 0. True negative, 98% times it was correct, because it said no fire, and actually 98% times it was correct. False positive, once again false positive will also be 0, because there's fire and there's no fire, it's 0. False negative, so 2 times actual में there was fire, but our model couldn't predict it. So my model was wrong twice, and model said no, that is why it is 2. So when we try to calculate accuracy, we first create the confusion matrix. You will also create the same look, you will also give it the same look, Tn, Fp here and Fn, and we try to calculate the accuracy with the formula. The accuracy is 98%. So accuracy is very high of this model, but still it's not a good model, because 2 times there is fire and it is telling there's no fire. So that is why we need another metric, which is called precision. So this was the explanation why there are cases why we need another metric. Why not accuracy is sufficient? It's because you understood that our model is always saying there is no fire, but 2% of times there was actually fire, and those 2 times can be dangerous. So that's why we are going for the second evaluation matrix, which is precision. So precision tells us how many of the items predicted as positive are actually correct. It focuses on avoiding any type of false positive results. So model is telling us that this is correct, but how many are actually correct? So if you look at the formula, it is out of all the positive predictions, that is TP and FP, how many are actually correct? FPs are not correct. FPs are not correct, we know, but that is a positive prediction. So how the items which are predicted as positive, out of that how many are correct? So it is TP divided by TP plus FP multiplied by 100. So once again, you will either calculate up to 2 decimals or percentage. So where should we use precision? So precision will be used for unbalanced data set where false positive is very important, because as you saw, false positive is in the denominator. If the false positive is high, precision will be low. So that shows us that if precision is low, the model will not be a good model. So wherever false positive, we need to focus on false positives, that I cannot tolerate any false positive from this model. We have to go for precision. But precision is not telling us anything about the false negatives, which is another error state. So for that purpose, we will go for another evaluation metric, which is recall. Now, recall tells us how many of the actual positive items are correctly identified by the model. It focuses on avoiding missing positive cases. So how many of the out of how many all the actual cases? So actual cases means false negative. False negative actually means that something has happened in reality, but the model couldn't identify. Model said no, but actually it was a positive case. So out of all the actual cases, how many the model could predict correctly? So the formula is true positive plus false negative. These are the actual cases. Model only predicted correctly are the TPs. So this is the formula for recall. Just a summary for you. Accuracy is the overall correctness of the model. Precision is how correct the positive predictions are. And recall is how many actual positives are found. Let us try to understand now which is important, recall or precision. Because recall focuses on the false negatives and precision on the false positive. So this is a case where a model has is giving lot of false negative cases. Model is generating lot of false negative. So what will happen if there is a forest fire and model is giving lot of false negative? That means the model is saying no, there is no fire, but actual there is fire. So this can be a dangerous case. Another case is viral disease. Model is saying no, this person does not have any disease, but actually that person has got a dangerous disease. So false negative cost can be very high in some of the cases, and you might get question ki what are the cases where false negative will be high? You have to go for forest fire and any disease. There are certain cases where false positive cost can be very high. That means if a model generates false positives, lot of false positives, it will be dangerous. In case of spam email, false positive means the model has said, yes, it is a spam, but actually it's a very important mail. It should have been redirected to the inbox, but it was not. And you can missing out important email can be disastrous. Another is false positive in case of mining. The model had predicted, yes, we have got some highly valuable resources at certain part of the earth, and suppose digging everything started with lot of manpower, time, resources, and finally there was nothing. So in case of mining, false positive can cost very high. So there are cases where recall is important. There are cases where precision is important. We cannot say recall is important. Recall always false negative, focuses on false negative. Higher the false negative, lower the recall. And precision. Remember P for precision, P for false positive, P for positive. Higher the false positive, lower the precision. So what is important then out of these two metrics? We have to work with both the metrics. So to work with both the metrics, we take into account another metric which balances these two. It's combination of these two. F1 score. So F1 score is combining both precision and recall, and finally giving us this formula: 2 times of precision into recall, precision plus recall in the denominator. Remember, numerator, everything is multiplication. This is for your remembrance. Denominator, it's plus. F1 score can go up to 100%, or if you're leaving it in decimal, it can vary from 0 to 1. So a F1 score towards 1 means model is a good model, and F1 score or F1 score like 100%, the model is a good model. And towards 0, the model has to be rethought. So if precision is low, recall low, F1 score will also be low. Precision low, recall high, it will again be low. Precision high, recall low, it is again low. So both precision and recall has to be high for F1 score to be high. And a model is said to be good if its F1 score is high. So that was all with your evaluation metrics. Next we come to ethical concerns. Whenever we are doing model evaluation. So when we evaluate an AI model, we must follow some principles. First is bias. Bias means ensuring that the evaluation metrics do not favor or disadvantage any group. So it should be equal for everybody. The results should be fair and unbiased. The next is transparency. Transparency means clearly explaining how your chosen evaluation metrics work and how the results are produced without hiding any information. Accountability means taking responsibility for the choice of evaluation metrics and evaluation method, especially if users are negatively affected by the results. So, bias, transparency, accountability help an evaluation, AI evaluation, to be fair, clear, and responsible. So, these are the 3 ethical concerns around a model evaluation. Shouldn't be biased, it should be transparency, and one should take responsibility for the choice of metric, accountability. So you should always remember, a good AI model is not just trained well, but also evaluated carefully. So model evaluation has to be there, and model evaluation is must. After evaluation is the deployment stage. That's all. Keep subscribing and liking for the next video. Bye bye.